Hello and welcome back. This is the Metabolism series. We're discussing the nitrogen metabolism, and today we're going to talk about the urea cycle, a very important metabolism pathway that we need to get rid of the toxic ammonium. So let's begin. As I said, ammonia is created from the oxidative deamination of glutamate. Glutamate was the guy who collected all the amine groups, and then he's going to deaminate itself to form alpha ketoglutarate, and ammonia is created, and then ammonia is converted into ammonium by adding a proton. And here we have a pretty interesting reaction. Okay, so ammonium is going to be converted into carbamoyl phosphate using the carbamoyl phosphate synthetase type 1, because we have the type 2 as well, but it is in the cytoplasm. Here we are inside the mitochondrion, remember it. So type 1 in the mitochondrion, type 2 in the cytoplasm. We will need bicarbonate, 2 molecules of bicarbonate and 2 molecules of ATP as well. That's why it's synthetase. A very important molecule that will stimulate this enzyme is the N-acetylglutamate. Okay, why is that? We need glutamate, acetyl-CoA and arginine to create this molecule. And this molecule is like a checklist, because it only appears if all of these three are present. This enzyme is the N-acetylglutamate synthetase, and arginine is going to stimulate this enzyme. If there is not arginine, we will not get the N-acetylglutamate. So it works as a checklist, because if all these three are present, then we will be able to convert ammonium to carbamoyl phosphate and start the urea cycle. If one of those is missing, we cannot start the urea cycle because we will not have the carbamoyl phosphate. So it's a very, very important molecule, this one. Okay, so outside the mitochondrion, we have the ornithine. If you remember from the degradation of the arginine, we have ornithine. Ornithine is going to be converted into citrulline using the ornithine carbamoyl transferase. So pretty easy. Ornithine, carbamoyl transferase. And so it will enter the mitochondrion, bind to this, react, and then get out as citrulline. Citrulline is then going to bind to aspartate, and together they're going to form argininosuccinate using the argininosuccinate synthetase, which needs ATP. Argininosuccinate is going to be converted in, guess what? Arginine. I told you this was a metabolite of the urea cycle. And we are going to use the argininosuccinase. So argininosuccinate to arginine using the argininosuccinase, and we release a fumarate. This is a metabolite of the Krebs cycle. And then arginine to ornithine using the arginase. In the process, we create urea. And urea is going to go to the blood and then excreted in the kidneys. So urea is a less toxic metabolite the body uses to get that ammonium, that very toxic ammonium, outside the system. Okay, so this was the urea cycle. I hope you understood it well. I hope you liked the video. If you did, click the like button below. Subscribe to the channel if you're new. Share this video to friends and family to let them know how they as well excrete that toxic ammonium out of their body. I mean, how they pee really. And remember that I will leave this diagram down in the description so you can have it. It's yours. Download it and start it. I see you on the next one. Bye.